All right, this is our introduction to our energy and climate assessment. I'm sorry I can't be there today, but I think this video will do enough to help you get started on where you need to be for today. Remember, this is a 2-day assessment, so I have kind of a minimum of where I want you to get today, and then sometime between now and the end of class tomorrow, you need to complete and submit your assessment. So first big thing, make a copy of this document and keep it in Google Docs. Do not bring this into Notability. You will need to keep it in Google Docs to do some typing. Please type your answers in a different color so it makes it very obvious for me when I'm grading it. There are 2 or 3 main pieces of the standard that you're being assessed on. Using a model to describe how variations in the flow of energy into and out of Earth systems result in changes in climate. Okay, so this is what you're doing, and these 2 things are what you are showing with your model. All right, so taking a look at the rubric, it's broken up into 4 points as usual. To show mastery, you need to design and explain a model that generates data to support explanations, predict phenomena, and analyze current systems. Explanation contains correct scientific content, obviously. So what you're going to be doing is the prompt for you, if you will. It is predicted that due to the movement of tectonic plates, the southern tip of South America will connect with Antarctica. So what is going to happen in this hypothetical situation is that South America right here is going to move directly south and connect right here onto Antarctica. So those 2 continents are going to connect. That's the hypothetical predicted situation here. What you need to do is you need to first and foremost, this is your goal for day 1, create a model that shows how the tectonic event of South America connecting with Antarctica in the future would impact global climate. So there's lots of information here, and it's really important that you follow these directions so you're not missing anything. The first thing says add details and labels to the model below to show the climate for South America and Antarctica. Okay, so your model needs to have a current and a predicted section. This picture down here is your current section. You just need to add some details and some labels down here. Okay, I've sort of cropped this out for you. This is the area I want you to focus on, obviously, because we're thinking about South America and Antarctica. Okay, but you can just draw right on here to show your current model, right? This is your current model. So you can say, oh, there's high energy here, there's low energy here, whatever. Okay, so after doing that, you will need to construct a second model showing the predicted changes, and you're going to insert that right in here. My recommendation for you is to open up a blank page in Notability and draw what you expect to happen due to this phenomenon event. Okay, so draw what the predicted scenario would look like. Then your models should show where the high and low amounts of energy are. Okay, you need to label where high and low energy is, not just hot and cool temperature, but also high and low energy. Your models should explain how both tectonics and ocean currents change the distribution of energy. So I should be able to look at your current model and your predicted model and say, okay, this student knows how tectonics have influenced the energy of that area. This student knows how ocean currents have influenced the energy of that area. This is the minimum of where you need to get to today. You should have your predicted model completed at the end of our first day. That's the minimum. That's the expectation. Okay? Day 2 down here, or if you finish your model and you want to start crushing ahead, great. The 2 climate phenomena you're going to be using are tectonics, thinking about latitude, and ocean currents. So there are 2 different explanations here, and you need to talk about both climate factors in each explanation. So the first one says, explain how the current energy conditions cause the current climate in both of the locations using your model. Be sure to include both climate phenomena. So using your current model, you are explaining how ocean currents cause the climate in this area, how latitude or tectonics causes the climate in South America and Antarctica right now. Okay? You're using your current model, so you should be making references to your model in your explanation. So South America is up here, and Antarctica is down here. Remember, you're talking about ocean currents and latitude. Then you'll be doing the same thing for your predicted model below. So you've already done the current. Now you need to do the predicted model. So what is going to change? How are ocean currents going to change the climate in your predicted model in South America and in Antarctica? How is latitude or tectonics going to change your climate in your predicted model in South America and then in Antarctica? Okay? There's obviously a lot here because it's a 2-day assessment. This is where you need to get to for today at a minimum. All right? So go ahead and start adding some details into this model right here, some high and low energy and some warm and cool. What is that going to mean? And then start creating your predicted model of South America connecting to Antarctica and start showing how that affects ocean currents, how that affects latitude, stuff like that. Okay? Remember, we'll have remediation on this. I want you to do your best to try to use these models to explain what you know about tectonics and ocean currents. All right? Good luck.